Imagine a discarded piece of metal, forgotten in a corner of a busy city. It could be an old car door, an old pan, or even the remains of a demolished building. What many see as trash, the metal recycling industry sees as an opportunity. This waste, instead of being an environmental problem, is the raw material for something extraordinary. Robust I-beams and high-quality rebars that give life to buildings, bridges, and large infrastructure projects. This transformation is not just a matter of technique, but a true revolution in the way humanity uses the planet's resources. Metal recycling not only saves billions of tons of natural resources, but also drastically reduces carbon emissions and the energy needed to produce new materials. But how exactly does this process work? What happens to that discarded piece of metal before it becomes part of a skyscraper? Today, we're going to explore behind the scenes of one of the most fascinating and sustainable processes in modern industry, the reuse of metals and their transformation into high-quality products. Get ready for a journey that connects sustainability, cutting-edge technology, and the future of construction. The transformation of recycled metals begins long before massive machines and furnaces take over. It all starts in a seemingly simple yet absolutely crucial stage for the efficiency and sustainability of the process: the collection and sorting of metals. Without this step, everything that follows would be impossible. Let's dive into this world where one person's trash becomes another's treasure. Imagine walking through a city. Around you, there are metal remnants of all shapes and sizes. Old building structures from demolitions, abandoned cars, discarded household items, aluminum cans, and more. Collecting these materials isn't just an act of urban cleaning, but a task that drives a complex economic and environmental chain. Specialized companies, recycling cooperatives, and even individual collectors play essential roles. They gather metals from various sources: urban waste, industries, construction sites, and scrapyards. Each piece of metal forms part of the puzzle that sustains the recycling chain. This stage isn't just about collecting anything metallic, but also identifying what can truly be reused. This is where sorting comes, in a process that is almost artisanal in essence, but in many places already benefits from modern technology. Not all metals are the same. Some are ferrous, such as steel and iron, while others, like aluminum, copper, and brass, are classified as non-ferrous. Each type has unique properties and specific uses, demanding meticulous separation right from the start. In manual sorting, experienced workers identify materials based on characteristics like weight, texture, and even the sound they make when tapped or struck. However, in large recycling centers, technology has stepped in to make this process more efficient. Magnetic induction separation machines, for instance, can distinguish ferrous from non-ferrous metals in seconds. A giant magnet attracts all the steel and iron, leaving non-ferrous materials behind. Another remarkable advancement is the use of sensor-based sorting systems that utilize X-rays or spectrometry to identify material compositions. This is particularly useful for separating metal alloys or identifying precious metals in electronic waste. Before metals can be melted and transformed, they must be as clean as possible. This involves removing contaminants like plastic, rubber, paint, and other residues that could compromise the quality of the final product. Metals are processed through industrial shredders, which reduce materials into smaller pieces, facilitating separation. After shredding, screening systems and air currents are used to separate non-metallic particles. In some cases, high-pressure jets are employed to wash away stubborn dirt. This cleaning is not just an aesthetic matter. It is vital to ensuring the recycling process is efficient and the quality of the I-beams and rebar produced is preserved. Another critical aspect of this stage is logistics. Transporting tons of metals from various locations to recycling centers is a challenge requiring careful planning and coordination. Companies use specialized trucks, often equipped with integrated scales, to measure the material's weight before it even leaves the. Additionally, digital tracking systems monitor each load, ensuring the metals reach their correct destination without deviations or. In a world increasingly focused on sustainability, this logistical efficiency helps reduce the carbon emissions associated with transport. Although technology has transformed many aspects of collection and sorting, the human factor remains. In developing countries, for instance, thousands of people depend on this activity for their livelihood. Recycling cooperatives have become key players in the sector, organizing workers who once operated individually and offering better working conditions and income opportunities. Moreover, companies and organizations invest in training programs to equip workers with the skills needed to handle technological advancements, and the result is a more qualified workforce, integrated into a recycling chain that combines tradition with innovation. Without effective collection and sorting, metal recycling would not be possible. Contaminated or poorly classified materials could compromise the entire production chain, leading to low-quality products and wasted resources. This stage lays the solid foundation for subsequent steps like melting and manufacturing new products. It's remarkable to think that a discarded piece of metal can soon become a support beam for a building or rebar, ensuring the stability of a bridge. This cycle of transformation is not just a demonstration of technological efficiency, but also a symbol of how waste can be avoided through creativity, teamwork, and innovation. At the end of this stage, metals are ready to face the intense heat of industrial furnaces, where they will be melted, purified, and But that's a story for the next chapter. After metals are collected, sorted, and cleaned, they are ready for one of the most fascinating and intense steps of the recycling process: smelting. At this stage, seemingly worthless scraps are transformed into a renewed, pure material ready to be used in the manufacturing of high-quality products, such as I-beams and rebar. The smelting process begins in industrial furnaces, operating at extremely high temperatures, capable of melting even the most resilient metals. Depending on the type of metal, the required temperature can vary. Aluminum, for instance, melts at approximately 660 to 4°C, while steel and iron require temperatures exceeding 1,500 to 4°C. These modern furnaces are designed not only to melt metals, but also to optimize energy consumption and reduce greenhouse gas emissions. Technologies such as electric arc furnaces and heat recovery systems are widely used to make the process more sustainable. As the metal melts, it transforms into a bright, viscous liquid, ready to undergo one of the most critical stages: purification. Although the metals have been cleaned prior to smelting, small impurities may still remain and need to be. During purification, advanced techniques are applied to ensure the recycled metal meets the quality standards demanded by the construction industry. One common technique is the use of slag, substances added to the molten metal that chemically react with impurities, forming a layer that can be easily removed. Another approach is degassing, a process in which gases such as argon or nitrogen are injected into the liquid metal to remove oxygen and other contaminants. This attention to detail is essential, especially for products like I-beams and rebar, which must withstand heavy loads and resist wear over. One advantage of metal recycling is the ability to create customized alloys. During the smelting process, other chemical elements can be added to the liquid metal to adjust its properties. For example, carbon can be introduced into iron to produce steel, while chromium and nickel are used to create stainless steel. This flexibility allows manufacturers to tailor materials to the specific needs of construction projects, ensuring strength, durability, and other desired characteristics. Once purified, the liquid metal is transferred to molds that shape the final products. For I-beams and rebar, this means creating long structural forms essential for the construction industry. The molding process can vary, but a common technique is continuous casting. In this method, the molten metal is poured into cooled molds, where it begins to solidify as it is drawn. This process produces long, uniform bars that can be cut to the desired. For I-beams, an additional step is required. The characteristic I-shape is achieved through rolling machines, which press the metal at high temperatures until it reaches the precise dimensions. And after molding, the metals must be cooled and heat-treated to achieve the ideal mechanical process. Cooling can be done outdoors or in controlled chambers, depending on the type of metal and the desired characteristics of the final. Heat treatment, in turn, involves processes such as quenching and annealing. These methods alter the internal structure of the metal, making it either stronger or more malleable. For example, rebar undergoes quenching to increase tensile strength, while I-beams may be annealed to enhance ductility. Before being sent to market, all products undergo rigorous quality control tests. These include dimensional checks, chemical analyses, and mechanical testing to ensure that I-beams and rebar meet safety and performance. Additionally, many factories use digital tracking systems to monitor each production batch, ensuring complete transparency and reliability for customers. One of the great advantages of the recycling process is the reduction in natural resource consumption. Producing steel from scrap, for example, uses up to 74% less energy than production from Furthermore, modern technologies help minimize carbon emissions and recycle the water used in the process. This approach not only benefits the environment, but also lowers production costs, making recycled products more competitive in the market. At the end of this process, what was once considered waste becomes something extraordinary. High-quality I-beams and rebar ready to shape buildings, bridges, and other critical infrastructure projects. These products not only support physical structures, but also embody a model of circular economy, where nothing is wasted and everything is maximized. The smelting and purification of recycled metals represent an impressive combination of science, technology, and sustainability. Every step, from melting to molding, is carefully designed to transform waste into top-quality products, essential for construction and the future of a more sustainable. This transformation is not just a technical triumph, but also an inspiration for what we can achieve when innovation is paired with environmental responsibility. And this is just the beginning. The journey continues with the transport and application of these products in projects that shape the world around us. The process of metal recycling, from collection to the production of I-beams and rebar, is an extraordinary demonstration of how science and technology can transform waste into resources of inestimable value. More than that, it is a powerful example of how humanity can evolve towards industrial practices that respect the planet and sustain development. Choosing to recycle metals instead of extracting ores is not just a matter of economic efficiency, but also an environmental imperative. The positive impact is immeasurable. Less mining means less destruction of ecosystems, less energy consumption, and a significant reduction in greenhouse gas emissions. Additionally, reusing materials prevents tons of waste from ending up in landfills or polluting oceans and rivers. Modern recycling plants are also investing in clean technologies that make the process even more sustainable. From air filtration systems that capture harmful particles to the reuse of wastewater in the industrial process, each innovation is a step forward toward a greener future. The circular economy model, which prioritizes reuse and recycling, is a trend shaping industries worldwide. In the metal sector, this concept goes beyond simple reuse. It creates a continuous cycle where materials never lose their value. For instance, I-beams and rebar manufactured from recycled metals can one day be recycled again. This means that the same material can go through several generations of use, continuously contributing to new construction projects without the need for further exploitation of natural resources. The introduction of technologies such as artificial intelligence, automation, and data analysis is revolutionizing how recycled metals are processed. Advanced sensors can identify different types of metals with millimetric precision, while automated robots ensure that the sorting and cleaning stages are fast and efficient. Beyond that, emerging technologies are opening doors to even more sustainable processes. Furnaces that use renewable energy, systems that capture and reuse CO, and innovative purification methods are just a few of the innovations promising to redefine the sector. The products resulting from this process, such as I-beams and rebar, are fundamental to the construction industry. They not only provide the strength and durability needed for large projects, but also represent a conscious and responsible choice by construction companies. Imagine a skyscraper in the heart of a modern city. Every beam and every piece of rebar supporting its structure could have begun its journey as a discarded can. This connection between disposal and renewal gives a new meaning to the idea of sustainable progress. Although we have already come a long way, the potential for improvements in the metal recycling sector is limitless. Ongoing research is exploring ways to make the process even more efficient, further reduce waste, and expand the range of products that can be made from recycled materials. Moreover, increasing public awareness about the importance of recycling is encouraging more people and businesses to participate in this cycle. As more scrap is recycled, more natural resources can be preserved, and more jobs can be created in industries that promote sustainability. What makes the metal recycling process so extraordinary is the combination of its technical complexity with its profoundly human and environmental impact. It is proof that human ingenuity and determination can tackle some of the world's greatest challenges, such as resource scarcity and climate change. Each piece of recycled metal that becomes an I-beam or rebar carries with it a story of transformation, innovation, and hope. It is a reminder that, even amid waste, there is unlimited potential for. And for those working in the recycling industry, each finished product is not just a construction item. It is a symbol of what we can achieve when we align progress with responsibility. Whether building bridges that connect cities or skyscrapers that challenge the skies, recycled metal proves that the future of construction can and must be sustainable. After all, the true strength of I-beams and rebar lies not only in their metallic composition, but also in the positive impact they leave on our. Looking at the process of metal recycling and its transformation into high-quality I-beams and rebar, it is impossible not to be impressed by the technical complexity and positive impact of this practice. It is a masterful combination of innovation, sustainability, and responsibility, reflecting how modern industry can balance economic efficiency with environmental preservation. Recycling metals is not merely an effort to reduce waste. It is a declaration of commitment to the planet's future. Every ton of recycled metal represents a conservation of natural resources, a significant reduction in energy consumption, and a decrease in carbon emission. Moreover, it demonstrates how waste can be transformed into essential resources for society. The I-beams and rebar emerging from this process are not just industrial products. They are pillars that sustain dreams, progress, and development. Whether in constructing buildings that shape cities or bridges that connect communities, these products symbolize precision engineering and a conscious choice for sustainability. By using recycled metals, the construction industry not only reduces costs, but also strengthens its role as an ally of the environment. Every beam and every rebar tells a story of transformation, where something seemingly worthless is renewed and returned to society with purpose and quality. What makes this process even more inspiring is the use of advanced technologies to improve every stage, from collection to manufacturing. Automated systems, artificial intelligence, and modern purification techniques ensure that recycled metal meets or even exceeds the quality of virgin material. These innovations not only optimize efficiency, but also pave the way for a future where recycling becomes the norm rather than the exception. Imagine a world where every piece of scrap is reused, creating an endless cycle of renewal and resource conservation. Metal recycling is a powerful symbol that progress and sustainability can coexist. It teaches us that even in the face of challenges, creative and impactful solutions can benefit both the planet and the economy. However, the success of this model depends on from individuals sorting waste to companies investing in cleaner technologies. Every part of the process is essential to ensure recycling continues to grow. And if there is one thing metal recycling teaches us, it is that nothing needs to be discarded forever. What appears to be waste today can become the foundation for something great. This vision inspires us to rethink how we consume, dispose of, and reuse the resources at our disposal. Every I-beam and every rebar produced from recycled metals is more than just a construction component. They are emblems of a more responsible and innovative future. They are proof that we can build not just taller buildings, but also a more conscious and sustainable society. Ultimately, the true strength of metal recycling lies not only in the quality of the products it generates, but also in the message it carries. We can transform the world, one piece of metal at a time.